Since Kafka is going to be the primary technology talked about here, let's get into the Kafka data strategy known as partitioning. By default, Kafka uses a strategy known as round robin, and the way this works is that you have a topic, for example users, that'll be broken up into one or more partitions. In this case, we have 3 partitions. So what happens when you submit an event to a topic, it's going to pick a partition 0, 1, or 2 for that event to go into. And it's going to use a hashing algorithm so that given the same key, for example 1, it'll always go into the same partition within a topic. So you can see in our example, when I use the key of 1 to create a user, probably user ID 1, it goes into partition 0. But then when I update that user, it also goes into partition 0. This is important to note because the order inside of our partition is what's set. But there's no way out of the box using the round robin strategy to be able to reassemble that original order when you're using the round robin partitioning strategy, because different keys are going to end up in different partitions. While we've talked about how data gets into the topic, what's important to understand is that how data is consumed from the topic. Consider that when you create a consumer that's identified by a consumer ID, that consumer ID is going to connect to all available partitions. And if there are multiple consumers using that same ID, they'll split those partitions. For example, if I only have one consumer, it's going to connect to each individual partition and it's going to be reading from it. So technically, any event that goes to any partition will be picked up by that individual application. However, if I then have 2 applications using the same consumer group ID, it's now going to split the partition between those 2 consumers. So in this case, one application is going to have 2 and the other one's going to be left with 1. What this means is that it allows you to distribute the reading and processing of those events based off the partitioning strategy. So in this example, if I'm storing what looks like to be user information as events, I'm going to have one application processing the events on its partitions, for example 1 and 2, while the other application is only going to get the events from partition 0. This is why the strategy and the ordering matters. And in this case, I'm using the user ID as the key for the exact reason of knowing that I need an individual application, for example, connected to partition 0, to always be getting the events for creating, reading, and updating or doing whatever with that user by ID 1. For example, if I had events sitting in another partition processed by another application, that application instance would get the event to update a user, for example, but it wouldn't make sense because it's entirely possible for that update user event, if they were dispatched at the same time as the create user event, to be processed by one instance before the other. And this is why it's important to understand the ordering within a partition and needing to understand the data going into that partition to ensure that an individual application connected to that one partition is able to do everything it needs to, only having that as the source of information.